just need to find the slideshow.
Yeah, and I gave you permission to share your screen, so you should be able to put the slideshow up. I don't see it.
Ask him how to share it.
So run your cursor at the bottom of the screen and it will have a green rectangle with an arrow that says share screen.
Great. Hello? Can you hear me? Yeah, I'm just trying to find the Google slideshow. I'll share the screen when I get it.
Yeah, I understand.
Can you hear me?
We do. Hi, Glenn. So
Hey,
we are in Olympia, Washington.
All
And,
right.
and they're really carrying the whole afternoon because they have lunar chair, then lunar table, 2 dice teams and 2 wheel teams.
Excellent.
And then to end the afternoon, we have 1 California team doing the dice.
Which California team is that?
So it's brand new. It was a young man, David, who you might have seen some of his emails, but he moved to California and he wanted to have a team. So we have a team there. All right,
Okay.
your PowerPoint is up. Awesome.
So we're the lunar chair. I'm Kid. Everyone.
I'm Mason.
June Lynn. Max, say hi. Yeah, and this is my Mr. Woodbridge. In high school. So I would like to go to is what constraints we had first off. It wasn't more about like any technical constraints, but more group constraints, like how could we include everyone's ideas and how could we get through maybe like an idea that we didn't know. And the main thing we developed through these was just sitting down and like having serious conversations, making sure to write everything down, include everyone's thoughts. And then we were able to process like some dimension from there, what we wanted to do, and sketches, and yeah, just all those.
I love that. No one has talked about that constraint of working in a team. That is awesome.
Yeah, we were all very different people. We all we made sure to include everyone's thoughts. That's an important thing. Teamwork like that. And here's just a timeline of what we had. Simon made a very good checklist of what we needed, and we were able to just figure it out from there. So I'm going to click first. This is what we first had for our sketches. Of course, we had some research done. One time it was $1.2 million transfer. We had some criteria that we needed. Simple, easy to assemble, lightweight, adjusted to 30 and 40, and hold about 130 pounds, I think it was. And we took inspiration from these chairs. I know these chairs didn't make it, but they had elements that could make it, and we tried to expand upon them. This is just some earlier ideas we had. We had a suction cup based chair, some type of stem that can reach up. This was a picture of a chair that we found was they said something, it was the lightest chair recorded. Just try to copy that at first. Wasn't the best. Had ideas finalized on October 12th. And it came down to this bar stool chair, or this more simpler chair that we actually had in our classroom that we could actually have ideas off of. And we took a vote and all decided on this one because we had it on hand, so we could easily edit it if we needed to. And it was also pretty light and sturdy as well. Then here's some dimensions and paper sketches. At first, we didn't know how to do CAD or HUNCH shape, so we kind of had to write everything down on paper. Here's So my initial ideas at first, the legs, and just be getting some dimensions of the chair. And then finally, paper, we were able to draw some pictures thanks to Max and Julian and Mason for making these amazing prototypes. We had some dimensions in inches right here. Over here, I don't know if you guys can see that, but there's all the chair parts assembled together. These parts can actually fold down at first. We're going to try to collapse it so it can be as flat as possible, but we might change that. A new part development right here. We also have some ideas ongoing. We also want to add Velcro, like detachable seats, so it can be easier to clean. Like maybe even get some crumbs stuck in there. You don't want that to stay. And also maybe how to make it grip onto the edge more, so we think of putting some rubber on the foam surfaces just to make it a little bit more stationary. And we also have some materials that we're thinking of using for our prototype. So for our cushion, we're thinking of using some canvas just for the cover, something cheap, something sturdy. Our chair legs PVC, something also cheap, something also sturdy. For our foot rubber caps, we don't really have or don't know how to make that yet, but we think if we can develop something in CAD and just use 3D printed filament to make it, it could be a good idea. And for our hinges and screws that we might also add, probably just use the basic 304 stainless steel. And yeah, so have some questions that we would like to ask you guys too. From everyone in the group, we just sat down trying to figure it out what we really wanted from NASA.
Hey guys, that's looking really good. Can you go up a slide or two?
Yeah.
Go up another one. Keep going. No, that's too far. I was looking for, you had a chair that was set up on the on one of those foam pads. There you go. So is this a chair that you at your school or something? Is that right?
Yeah, it's just like a model we have, so we can have our hand and change it to anytime we want to.
Well, and so the main parts, there's the legs are one part, and then the seat is another part, and then there's a couple of other components where it's just caps or whatever, but it's a really simple component, or a very small number of parts, right? Very good. I like that you're looking at that. So is that the one that you're modeling from for your CAD pictures there?
Yeah, definitely. And since it's so
big, okay,
we can really just add it. This we actually one of our things read the handle said that the material for the linear housing would be this, so we tried to just emulate like how can we make it more sturdy and apply some friction against it. Didn't do that all. I just put down rubber.
Okay. No, and I like that. One question I've got is, it looks like from your modeling that the legs are going to take up a significant amount of space when you launch them. Is there a way to separate them so that they're two pieces instead of one?
Yeah, of course. We're definitely going to have some type of screw system that we can assemble it, take up way less space.
It's a little hard to hear them. I don't know,
Yeah.
Mr. Bridges, if you can
If
give
you
it
can just put
louder.
them a little bit closer to their
Computer. Whoever's talking, sit right by the computer.
Is this better?
Way
yeah,
better.
that's great.
Okay. Yeah, so about the chair, we were probably just gonna implement a way, like maybe some type of screw or hinge to make it fold down before you assemble it, just so it could take up way less space. Because when the chair is definitely assembles, it's gonna be pretty, I wouldn't say big, but it's gonna take up a significant amount of space. So when you definitely not sitting or eating, probably want to fold it down, collapse it, put it away. Definitely have more space in your habitat.
Well, and I'm not thinking about folding it away once it's on the moon. I'm just thinking about for transporting it to the moon. Can you make it so that it's smaller? Once it gets there, I don't think that we're going to collapse them or anything. I think they're going to be used as chairs.
Yeah, we're probably just gonna have it all disassembled and I wouldn't say little parts, but just like segments, and it's all packed together. It's not going to be pre-assembled. Yeah.
No, I think that sounds good. Good job, guys. I like where you're thinking.
Thank you. And we have some questions for you guys that we thought of that we just want to ask real quick. So what does the bottom of the astronaut shoe like? This is just to help us like to add maybe more grip onto the chair so it can stay without moving. If you guys have a picture of that. And also
We don't have any pictures of their shoes. I would expect that it's going to be similar to some types of running shoes, but that's actually to be determined later on as well.
no problem. And what do you guys have any suggestions for what materials we should use? We're kind of still brainstorming on the materials, and we're kind of at a dead end, so to say.
What ideas have you come up with so far for materials?
Carbon fiber, PVC. We try to limit the usage of steel and metal, but from where we're going, we might have to use a lot more than we anticipate.
And that's fine. Carbon fiber is a nice one, but you know it can also be pretty rigid. It doesn't flex like plastics or even fiberglass. And so think about comfort as well, right? So for example, you're modeling after that plastic chair. Are those chairs comfortable for you there at school?
Yeah, it's not bad, but we can definitely.
Yeah, and so I'm not saying you probably can't use the same kind of plastics because the requirements for flammability make it difficult. However, there's probably some things you can choose out of that. I suspect that you're probably going to need to use some aluminum and steel in some cases just for strength and durability. But I think that you guys can look for materials that'll work for it as well.
Thank you.
I got to say that I really like your bare bones design there that with the setup and the fact that you tested it on the foam rubber. But the one thing I was looking at that with at least the chair that you're using as an example, and you one of the things that I'm a little worried about when it comes to chairs and things like that on the moon is you were saying you're trying to go like light materials, low mass, which means on the moon they're going to easily be knocked around and stuff like that. So one of the things that we saw in another team might be something you want to consider about is that those runners you have along the bottom that it's actually on the floor.
Mhm.
Could you make that into a container of some sort that people could be used as storage and would give mass to the bottom, would make them would lower the center of gravity on your chairs, which would make them more stable. So just a thought, but I really like what you've done, especially the last thing was the cushions you were thinking about. Removable cushions, actually a nice idea.
We're definitely taking into the container part. That's something we haven't thought of. Definitely something new that we should look at.
Okay.
Looks like our time is up. 12:15. I like to thank you guys for taking the time to come out here today and talk to us. Thank you.
No
Thank
problem.
you so much. Nice job.
Hey, did you get something?
Good job, team. Keep it up.
Yeah, I like that classroom chair. And then put some cushions on it and you're all right. So don't be afraid to sew.
All right, they are trading places.
Thank you.
We do have a sewing machine and serger in the classroom for them, just in case. So
Awesome. That's what I like to hear.
Yeah, we should.
This is going to be a lunar table to go with the chair.
Yep. Where are the table? Let's move the microphone. Oh, yeah. All right, there we
Are you able to hear us?
Yes.
Okay.
Yep.
Which computer do we pull up the slideshow on? This one?
The one you're sitting at's fine. Just use the one you're sitting at there.
You know, that chair made me think of baby high chairs. Have you ever seen the high chair that actually just attaches to the table? It doesn't have any legs.
Yeah, I don't think I had one of those for my kids, but I remember seeing them.
Yeah.
That was kind of cool.
Yeah, I've never seen that before.
Yeah, that's an old-fashioned type of infant table seat we used to have. It wasn't a high chair, it just attached to the table, so you could bring it anywhere as you went.
Huh, interesting.
We still have one of those that we use with the grandkids.
Yeah,
Just, that gives me
Never
an
throw
idea.
anything out.
I mean, since you're making the table and chairs.
Yeah.
That reminds me of the high chair. We had one from my wife's grandparents, that the actual bottom of it, there was a bottom section that folded out back to lower it down to be a regular table, chair at the table. So could a variation of that be used for the dual height here, and that
Yeah.
one that goes in the back be the storage unit?
Yeah, definitely. Go Google old-fashioned high chairs.
Yeah.
That is definitely something to look into. That might,
Just a
That's a
thought.
cool idea.
You want to try and log in?
we're getting
No, we're not. Our email's not.
Okay. You have to go through. Oh, you got it.
Oh, there we
On.
go.
Okay, it's that one.
This one.
Yeah, no, this one. The yellow first one.
There we go. Okay. Right, then you remember to share from Google or from.
I haven't been on
Zoom.
in a while.
I know you guys all got Zoom.
Yeah.
They're in school now.
Yeah, it's been a while since we've had this.
That's working. Yep, we see it.
Okay.
All right. So this is the slideshow for our lunar table. We have Grace, Wyatt, which is wearing the green hat, Dustin, and then me. Grace is missing today, but here's some about where's my slideshow?
Yeah.
Where is that?
Top right.
Oh, slideshow. There we go. There we go.
Yep.
Yeah, there you
Okay.
go. Cool.
So about us, we are from Olympia High School. Our teacher is Mr. Woodbridge, and those are our names. And then our mission is to make the table. We chose the table out of all the projects because it is the most useful and multifunctional. With an adjustable table, you can place and hold items to make it a workspace and have it be a place where everyone can hang out and have a meal. With this design, we chose to go a route of non-inflatable table. We think that, what's this? We think it will take less gas and be easier to assemble for the astronauts if it's not inflatable.
Good.
Do you got it, Dustin?
Right. So for our table prototype, we chose 2 pieces of coral plastic, some nylon sheeting, PVC pipes, which are just for the prototype. We're planning on using carbon fiber for the actual table legs, C-track fittings to attach it to the floor, and fiberglass rods for some extra support. The coral plastic, we have 2 layers that will support each other in both directions. So it'll make it lightweight and sturdy. The nylon sheeting will help it be heat resistant and will give it a clean surface. The PVC pipes will demonstrate the adjustable legs. We've drilled holes into them for a pin system to be able to adjust them from 30 to 40 inches. The C-track fittings will allow it to be easily installed to the floor. Later in the design, we will look at better materials, anything that might be lighter or less expensive, and maybe stronger or more flexible. The assembly process, we already have the tabletop. The legs will be able to fold underneath so that it's compact and stored easily. The materials we chose are lightweight, so just better for sending it into space. They're easily accessible to us right now, and the prototype design will display each function of the table. The dismantling process of our design will be easier to deal with on Earth, and it'll be a better alternative than an inflatable design.
All right, cool. So we did do some testing because it's got to be heat resistance. So first we tested the nylon. It didn't burn, but it melted pretty easily. And then we also tested the chloroplast. Now the outside plastic layer that caught fire, but the insides layer that didn't really. It did pretty well. I mean, it eventually, caught fire, but it wasn't a big flame. It just kind of like went out pretty quickly. So that worked out pretty well. So yeah, on the next slide, we got some pictures. That first one is measuring the chloroplast that we used because we did a half scale for our model. Then the next picture to the right that's going to be like the leg design. So inside that black PVC, there's another PVC with holes drilled in it, and that white pin that'll be on a spring, so you could adjust the table height to whatever you want. There's going to be different settings. To the right of that, us testing the chloroplast and then the nylon, and then the very right picture is like the tabletop. We were thinking maybe doing like some sort of support beams or something like that, help it a little stronger.
All right, so we have a prototype with us right now that I finished printing yesterday. So this is the attachment piece for the table legs, which will attach it to the C-tracks. Yeah, it has the L-shaped bracket to help lock the pin in place so that it can be easily moved into place to lock it vertically.
Are you holding it up or something, or are we just looking at the picture at the CAD? Oh, okay, that's fine.
I have.
Yeah.
So I'm just explaining it right now.
Okay, that's fine.
The 2 notches on the bottom will lock it in place from moving side to side. And that's the last slide.
Questions?
Okay, so that's show us your locking mechanism. Go ahead and
Stop sharing.
stop sharing so we can see that.
Is that, oh, there, stop sharing. Okay.
Okay, so we don't have the pin that goes inside just yet, but we have the casing for it.
Okay.
These 2 separate pieces, because it's a little bit smaller, the only way we have of attaching these 2 pieces is glue for now.
Okay.
But once we move up to the larger scale model, we'll be able to use screws or other items to hold it better.
And so you're going to have 4 of those, or how many of those do you need?
If we have any C-tracks that are exactly 24 inches apart from each other and we can have all 4, then we could do that. But it's likely that we don't, so we could have only 2 of these attached to 2 table legs, and then for the other 2 we have wheels or just flat bottoms to lay on the floor.
Okay. Do you have any of those other components so you could kind of hold them next to each other so we could see how they fit together, or what you're thinking?
So can you elaborate? Can you go further, please?
How do you mean? Are you guys looking at the slides?
No, we still have
Okay.
slides.
Okay.
So these 2 pieces,
Right.
I'm not sure how well you guys can see this.
No, we
I
can
can
see
see the
them.
pieces okay. I'm just not sure how they. I saw that you guys were building some other components, and I thought maybe you'd be able to show us how these fit together with some of your other components.
Over by my basket over there, you have the PVC pipes. Could you bring the white one?
In your bin.
Not in my bit, just like right in front of the ball things. Thank you.
So you have this thing, you wanna attach it to the floor, using the C-track and am I right with that? Is that what you're saying?
Mhm.
And and you're talking about being lightweighted and everything like that. If it can attach via C-track, how do you propose to get this thing so it doesn't like bounce around and things like that? Or do you have any other ideas that way?
I don't think we have any other ideas, not from me specifically. So we have a small model of the table leg here.
Mhm.
Okay.
On top of this piece that would slide onto the end of this, we would glue that in place as well, or put some screws in there to secure it to the leg itself.
Okay. And so that's all right. The other piece I saw that I was curious about was you had a big, was it orange piece of cloth with a PVC pipe going diagonally through it. Is that right?
Yeah, that's the tabletop with the nylon sheeting and the plexiglass, fiberglass rods as supports.
Okay. And so were you going to inflate that to give it the rigidity of a table, or how are you doing that?
We have 2 pieces of coral plastic inside. They're crossing each other in 2 separate directions to give it support in both directions. And we wrap that in nylon sheeting to make
Okay.
it a little bit more heat resistant and to have a clean surface.
And that sounds good. How are you going to attach the tabletop to the legs?
I was thinking of a frame going around it, but we haven't really discussed that all that much.
Yeah.
Okay.
We were thinking about maybe making some brackets that we could attach to the legs that are on the table, so that the legs will hold in the table. But we still need to make the brackets and do that stuff.
Okay. No, that sounds good. Okay. Gene, did you have any thoughts? Oh, go ahead.
I don't know what your thoughts are, but I'm inclined to encourage this team to think of alternatives to C-track as well. We don't even know whether C-track is going to be adaptable on this floor. And you can imagine that they're not going to just have C-track going everywhere. So even if it were something that could be installed, it's probably going to be very limited in its location, which means this chair will only be limited to where the C-track can go. So
Yeah.
I
Table.
think
Yeah.
you definitely need to be thinking about, alternatives to that.
Yeah.
Maybe an alternative could be attaching it to the table somehow to keep it secure.
Okay.
That's what we were talking about with that little child.
Well, no, these guys are developing the table, not the chair, right?
Yeah,
And so
Oh, right. Sorry.
no, we've seen several today, so we're not. The Gene, did you have some thoughts?
Well, I already brought up the one thing there. I was wondering, and especially if we can't attach it to the floor, we need to, these tables need to have some mass or else they're going to be knocked around. And so consider something along those lines, somehow giving it some mass, but that could easily be something as simple as adding something lower of container sort or something that will get it that way. Do we want to bring things up to the moon for mass? Probably not, because it costs. Are there things, is there some other way we can work around that? I'll let you guys think about that.
Yeah. We were told that it costs over $1 million to send a pound of space. So
Exactly. Yeah, one problem, you solve one problem, another one pops up.
Right. And so keeping it lightweight makes good sense. But can we use the bottom of it for some other storage that might be able to add weight to the bottom of it, is where we're going there. I had not thought of that. It was actually came from some other students that were thinking. And so it's a way of putting some mass into your table without bringing up extra mass for it. So anyways, I like your ideas. I really like the way that you've put together your tabletop, and it sounds like you guys are still working on how you want to attach that tabletop to the legs. But I think you guys are going in some good directions. And just so you know, nylon is not very very flammable as part of the deal, but using it right now for your prototype is perfectly fine. If you're going to be using cloth, it'll probably be something like a Nomex material later on, just because it's a non-flammable kind of material. But keep thinking on this, because I think you guys are going good. Dave, did you have any other thoughts?
No, I think that pretty much covers it. It is one of those things that, Glenn, your idea about this flooring material would be, again, to think about some foot or base of these that, increases the friction to that floor. Adding mass is one thing, but I think that you can also just think about that contact surface and probably, try to optimize that as much as you can.
All right. Yep.
So I really like your lightweight tabletop, and that if you turn your chair upside down, that maybe could be the storage area, and then make another spot for the person to sit in.
Yeah.
Use this because actually the cool factor is somewhat important. They don't want, they want cool furniture. And maybe that could also accommodate the two different heights. You have two different levels. I don't know, but play with it. It's a good design. It's worth pursuing.
Yeah.
Yep. All right. Well, I think our time is running out.
Okay. I love that you guys are keeping time here. All right. So let's move on. Thank you so much for that.
Yeah.
For all that work. That looks pretty cool.
Good job, team.
Thank you.
guys for feedback.
Yep.
So the next we have two dice teams.
These are going to be my first dice teams I've seen people do. So cool.
Go ahead and send it to.
There's a lot of dice teams. I'll tell you that much.
Good.
They love this project, Gene.
I don't have it. It's your base camp. Here, hold on. I can pull up my base camp faster.
I don't think it's in base.
It's in like star slot.
I don't think that's
Do we sign in Google account?
You don't need to unless you're showing something.
Oh.
Were you going to show something?
I think.
The base camp. No.
it's
Do you dice A or B? Thank you for your patience. So we pull this up. No, you guys. Did you put it here? I don't see your on shape. I don't see your.
I don't think it's in.
Okay. So. There you go. You can just sign into Google. All right. You guys can start talking while you pull that up.
Yeah.
So, we are gonna make like a container that then like holds the dice, and then the lid you can take off, and on the underside it has some metal that will attract these little magnets that we have. And those magnets are inserted into one of these dice. This is a D20. This is the only one I've designed so far. So we'll 3D print the dice, and then they'll have these magnets in the sides with like or vinyl or something covering it to show the number. And then you roll those like in the container, and then they go and stick onto the top, like the lid. And then when you take the lid off, it'll reveal your roll.
Okay.
Go ahead. I'm sorry.
Oh, no. Okay, so when you put your dice or when you put your magnets in there, are you pointing them all in the same direction so that all the norths are pointing out or all of the souths are? Okay. So that means that if you have multiple dice in there, they'll kind of repel each other. Is that right?
Yeah, they should. But then they'll still stick to the metal on the top.
I'm okay with that. That's some interesting ideas. All right, go ahead.
We see your PowerPoint now.
Oh, there we go. So for an introduction, he kind of just ran through the design, but we think it'd be nice for astronauts to be able to like use this like machine in space, or however you so call it.
Is that just a container?
Yeah, that's the container that it was showing on this screen. It has it on this screen as well. It's 7.5 inches tall and 3.5 inches wide and long. And I felt that would be like a good size because it needs to be able to contain all the dice, but then it also can't be like super huge because then it would be really inconvenient to carry around. And so it should still have the randomization that normal dice have, but it works when there's no gravity. And so on the right side there, you can see the dice bigger. It's just a D20 with a bunch of holes in each side so that the magnets can be inserted. Next slide.
So where's the metal on that one on your box?
Wait, go back to the. So the lid in the middle picture, you can see the lid there. That's the underside of it that we're seeing, and it would be right on the surface of that.
Okay, sounds good. Is there a reason? Oh, go ahead.
We needed something that would be contained in space because we were a little bit worried about if we did design the dice out of a container, it would get lost or worse. And we also wanted something that could be small enough that astronauts could take it wherever they want to take it and whatnot. We also needed to provide something that would work well in zero gravity. Sorry. And we needed something that would be robust enough so it wouldn't take away from the dice. We wanted something that could be versatile in that way. We also wanted something that would be pretty durable because, you know, if you're in some sort of contained thing for a while, sometimes things can get beat up. And so we wanted to make sure that it wouldn't get beat up over time. So yeah.
Very good.
You want to do the resolutions too, so
Okay.
they know how we solve them.
The roller is a little bit large, so it might be that it could be a little bit too large for its environment. The design uses magnets so that it would last a little bit longer. We were originally planning on using double-sided tape, but then we realized that that tape would not last as long as the magnets. And the magnets might lose their strength over time, like 1% of their strength. So we do have some more testing to do on that. But otherwise, I think we're pretty okay on that. Oh, the dice could bounce off the walls. So that might be something that people might want to be a little bit, just, be careful with, because we don't want any dents in the walls. So, yeah.
Well, I gotta say, speaking as a person that, I mean, I have my own dice and I have those exact magnets. I didn't think about that. So I'm really pleased that you guys came up with an idea like that. I'm very curious to see the results you have of rolling these and things like that. I don't know how well they'll roll well with it, but be kind of cool. So testing before the critical design review will be imperative.
And it does only have one magnet in there right now, but there will be one in each side.
Right.
So
Okay.
I think it's going to be random, but we'll have to wait and see.
Exactly.
So one concern I have is that do they need to be the neodymium magnets that are so strong? Strong magnets could be bad if they, get away and bump into somebody's computer or something.
We'll probably experience with some other or experiment with some other magnet types because we are worried about how strong they are and that we might not be able to roll at all. It might just immediately go stick to the lid.
Sounds good.
You might try something like a refrigerator magnet, these like things that you can stick on a metal surface, signs. You could probably punch those to whatever size you want and use those instead.
Yeah, that's a good idea.
Well, and remember, in zero gravity, you may not need, a whole bunch of strength. But I like your design. And you said so far you've only done a D20. That's actually kind of tough to CAD up. So I applaud your skills there. That's great.
Absolutely.
Thank you. Thank you. Good.
Okay.
Before we use Bennett,
Another question for you. So I noticed that you've got a rectangular box for doing your rolling. Is there a reason you want rectangular as opposed to cylindrical or spherical or elliptical? Or
so we're gonna make the walls of it, not the lid and the different other parts, the dice, but we're gonna do just the walls of acrylic. We're gonna laser cut some acrylic because then it's transparent, so you can see the dice actually rolling, and I think that adds to the experience a bit. And
I think so too.
I think it would be very difficult to laser cut a cylinder.
Well, and part of what I was thinking is that at least for a first demonstration to see how good your idea is, you can use like a plastic peanut butter jar or something like that and be able to see, is this working the way you want? I can see some good reasons as to why you might want cylinder or rectangular, just because it gives you a different rolling component, as you kind of shake it around in there.
Yeah.
So just some thoughts for you.
And we over the weekend we tried to print we were 3D printing the box before we actually tried to laser cut it, but it failed over the weekend, so it failed twice actually, so we didn't get a chance to present that.
Understand.
Okay, Gage. The microphone.
Okay.
I'm gonna come over here.
You can read.
Oh yeah, you got a comment? Go ahead.
Before we decided on using magnets, we were planning on using a sticky adhesive.
Gage, can you come over here, because the microphone's over here? So.
Yeah, we can hear you okay, or at least I could hear you fine.
But
And so
So it wasn't as simple as we thought originally with the adhesive, because then it wouldn't be robust, as I said earlier, because you would have to replace it regularly. So we just decided to do magnets instead. And then, yeah, as I mentioned before, the acrylic, because it makes it so that you can see the dice inside as they're rolling.
I think seeing it is very important. It gives people confidence that it's random.
Yeah.
Nice job, guys.
Hey, so I've got another thought for you. Oh, go ahead.
And this is just like who we are. I'm Trevor, and I have a twin brother and 2 dogs, and I've lived in Olympia almost my entire life.
I'm Isaiah. I'm from Florida. I have plans to go Gary Howard College. I have siblings and I have a dog. There's several others. And yeah, it's me.
I'm Olivia. I've lived in Olympia my whole life. I've got 2 cats, 1 dog, 7 birds, 12 chickens. This is my last year of high school, and I plan on going into medicine.
Excellent.
Now, none of you put down whether or not you were gamers. Did you pick this project because you play games or not?
I think we
Maybe. I play The Sims 4, so I can't speak for anyone else, but I don't know how much that counts.
And Kate, I have 3 dogs. I used to live in Nevada, and all I know of is that I'm currently a gamer.
Excellent. So what kind of games do you guys play?
I'm more of a Madden and
Yeah.
World of Warcraft.
That's all right.
Same with me.
Video games?
I more play video games than kind of dice
type of
games.
guy. Yeah.
Okay.
I think we're about out of time. Is there any questions?
Actually, I got one more comment. Okay, so number 1, we have to keep this random, right?
Yes.
Number 2, we have to keep it fun. If it's not fun, we're not taking care of our main objective of, mental health. And then 3 is what kind of style can you give it, right? Meaning that, that style can be part of that fun. And so consider, if I get a dice tower, it's shaped like a dragon or a castle or whatever, but you're going into space. Now, these are all, you guys are going to be, let's say that you are the NASA astronauts. You don't need NASA logos. You want something that makes you think of, this is a cool thing, and I'm playing dice in space. And so make it as cool as you can, okay? So
Okay.
think about style. What kind of style would you want to have on your dice chamber? All right?
And to test your ideas, just turn your dice chamber upside down and see if the magnets fall off of the lid that you've done.
Okay.
All
That
right.
does-
Good
that
job,
just-
team.
Nice job.
Thank you.
Thank you so much. And now it's the second dice team.
All right. And then, because your dice be right.
Yes.
Go.
Yep, you're sharing.
This over.
Okay, so
Perfect.
we're the second dice group. I am Grace Masika.
And I'm John Christensen.
Okay, so the problem we're solving is that we're creating a dice that works in space, and we have to preserve the randomness of the dice as well as the fun that comes with playing with it.
The constraints for this project where you must be able to handle at least 6 dice at a time, and you must be able to use it for all kinds of dice from D4 to D20, and that it must not leave a residue, and it's easy to use. So
So our process, these are some of our initial ideas. So we first started looking into the centrifuge system, but one of the cons is that it's hard to use it. So it's not the most simple design. And then we also thought of the catchment system, which would preserve the feeling of rolling a dice, but there are a lot of ways that could go wrong. And so kind of like the last one, it's not as simple. And then we also thought of a plunger dice system, which you can see in this image on the side. But it doesn't preserve like the feeling of rolling a dice. And there were some problems with the D4. And then we also thought of magnetic dice, which would be a simple design, but there are some possible magnetic residue and there's a chance of it not working. And then there are also corner magnets, which is kind of similar. There's some concerns about the wear and tear on the exposed magnets and also the alignment with the Earth's magnetism.
I've never heard of corner magnets like that, used like that before. Very cool.
So this was our research. We decided that our magnet would be a sphere that's actually magnetized to preserve randomness and also to be able to use that magnet in all different types of dice. We're considering using neodymium, but that's not like a final option. We're just still researching and trying to test it out. But it's because it's lightweight and it's also one of the strongest permanent magnets. And then we're thinking of using an iron plate because it's ferromagnetic, so the magnets will attach to it.
And then the materials were just 3D printed dice. I don't know if you can see it like this. That's hollow on the inside with a magnetic sphere in it, and then you just roll that at a magnetic or a plate that is magnetic, and then it works to the magnet would be attracted to the plate, and it would, yeah. And then this is I don't know if you'll be able to see it, but this is the inside of our D4 that we printed that you put the ball into.
Okay.
The advantages of our idea is that it keeps the look and fun of the dice, and so there's not much change between rolling a normal dice in like on Earth and rolling dice with a magnet inside of it in 0G. It's also lightweight, and there's no real chance of it like not working for some reason because it's very simple. And then here's a link to our design.
Just show.
But it's just the same thing pretty much. If it loads.
There you go.
Yeah, so here's just the dice and then the inside of it. And then this one we printed with the numbers like already done into it, but we don't really know if that's something we would do for the final design instead of like a sticker or something that's put on the magnets. That was just an idea.
So on this one, let's see, on other versions I've seen, they have a spherical dice and then they have the shape inside that allows the magnet or the metal ball to kind of roll around, and that's what determines it. But here you've actually kind of got two, don't you? Because the outside has a shape, but the inside also has a shape. Does that sound right?
Yes. The spherical dice were actually what gave us the idea for having the thing inside of it.
Yeah.
No.
I'd like to make a suggestion that I really like this idea where you have the shape inside that kind of the round ball would fall into those and kind of pull it down. Make a version of the same die, like a D6 that you have here, with not only this shape inside, but then do one with a sphere, a hollow sphere in the center, and see which one is more random. I'm curious about the shape and whether or not that would change how when you try to roll it, and whether or not it would magnetize stop it faster in this shape versus a round shape. But I have no idea. This is, again, I love it when students come up with ideas that I never thought of.
I like this idea as well, and it's funny. I had another set of students that had the sphere on the outside, and I asked them to try this idea as well. And so having two teams that are working the opposite directions of each other, I think is really valuable here. I like what you're doing, team. Good job.
Here.
Now, are you planning to have a magnet in the middle, or are you planning to have a metal ball and then a magnet on the outside? What are you thinking?
We don't really know yet. We don't really have spherical magnets here.
Yeah.
So the current plan was to put a metal ball inside of the dice and then do a magnetic plate that it would go onto. But the plan is to get also a ball magnet and put that inside to see which one works better.
So I want to say, like, about 7 or 10 years ago, there was a toy where it was spherical magnets, and then it got banned because I think they ended up some kids swallowed multiple of them, and they ended up having problems. You might be able to find some of those from, if you ask around some of your friends, they might still have them or something. I know my kids still have them somewhere. You got some? I'm sure I've got some at the house. I'm just not sure where they left them.
Actually, you know who might have some in your school? Your chemistry teacher.
Oh.
For the atoms, for making atoms. They were big for about 2 years, and then they disappeared, as Glenn said, off the market. So they might actually have them in your chemistry classes for bonding type things and all that.
Definitely.
I'm checking in my desk. I don't see them in my desk. Okay, good job, team. I like what you're doing. It also looks a little bit difficult in terms of the CAD to be able to do like a D20 with one of these. So I think that's interesting. Good luck on that. I know that it's going to be a little bit of trouble. So I like what I'm seeing.
Thank you.
Thank you. I think that's it.
Yeah, that's it.
Oh, very nice. I do like the idea of that you're moving towards, because that would be just like throwing dice on Earth.
Now wait, can you guys go back to what are you throwing it into? What did you have a decision as what you wanted to try?
The current idea was just just throwing it at kind of like a wall or something like that, but we could make like the dice A group had, we could make sort of a box or something that you threw at.
I think we're thinking more of just like a metal plate or like a magnetic plate.
Yeah,
but
we will
Well,
do that idea.
Look into it, and I'm not opposed to it, but I think depending on the strength of the magnets that you put in there, you may end up having to throw it into a box just so it doesn't ricochet everywhere in zero gravity.
Yeah.
Keep going on this. I think you guys have some good ideas.
Thank you so much.
Thank you.
I think that's
All right.
Okay, let's get the next one up here.
We have 2 learner scooter wheels teams from Olympia.
Here's your punch. Okay, where's your base camp? Here we go. Who's doing the presentation? One of you has to be here.
How about you guys play your computers over here so they can actually hear you too.
Okay, that's fine. Can you hear us?
Yes,
Oh, never mind. Never mind.
we hear you.
I thought they were leaving me in the dust to do all the talking.
No,
No.
we would never.
Are we ready?
Yes.
Yeah. Okay. Oh, this one has. Yeah, this one has camera on too. Okay. Sweet.
Share your screen.
There
we go.
Right, okay. No.
Yes.
Let me move Zoom out of the way. It's being kind of messy.
Yeah, just push it aside.
Yeah, I got it. All right. So, hello. We are. I'm not sure how many of them are, but we're one of the tire, the scooter wheel.
We're the only one at our school.
No, I think there's one more.
Not tires.
Yeah.
It's the bear time. It's the bear time. Oh, it's the bear time.
Yeah. Anyhow, that's beside the point. We're doing a scooter wheel as our project. We spent a long time looking at materials because it's a wheel, so it's gonna be like it's gonna take a lot of wear. It's gonna be a lot more abused than like the dice might be or the chair. It's gonna the moon dust we've learned is pretty hard on most materials. It shreds it up pretty badly. So we spent a long time looking into this. We want to use for our final product some solamide foam, which I think you guys at NASA actually had some say in the creation of that, if I'm not wrong, and some steel, which I know is heavier than titanium or like other metals, but we actually do have a specific reason for that steel right there, which we'll get to later, and Kevlar, because we know that that's pretty durable and it's flexible too, which is important. Right now, obviously, we don't have solamide foam, which is quite hard to get our hands on, or very specific types of steel to use. So we've just been using some 3D printed plastic and silicone we've molded, and just some Kevlar fire hose actually. So we're making do.
Couldn't really find the prices for the materials because I didn't really know where to look. Couldn't find any good pricing. Sort of you need to like reach out to the individual company. But we found the density range of solid foam to be 0.34 to 0.55 pounds per cubic foot. The high alloy carbon steel can withstand temperatures lower than 196 degrees Celsius, which would be good for space.
Yeah, that we found. So, well, I guess you should probably know. Yeah, you mind if I interject? Yeah. So we know that there's a lot lighter materials than that high carbon or high alloy, low carbon steel. Like I said, titanium, aluminum, probably a few other metals I can't name off the top of my head, but they don't work as well when the temperature gets that low. They'll start to get more brittle, which is obviously a very big problem if it's going to be absorbing impacts for any amount of time. And they do work equally or better at high temperature, but if they work only half the time, then it's not gonna be worth it.
And then the steel alloy weighs about like 7.86 grams per cubic centimeter, or 716 kilograms per cubic meter. Again, we don't know how much we need and the price of these. We need to get like a quote, and they'll probably try to get us to buy the huge bulk if we try to look into it in the first place.
Let me scoot this along. Why did we do this? It's I think I already went over this actually. Silicone's easy to find. It's mainly to test for traction. We've gone through a ton of different tread designs. We did like a kind of a chevron symbol, not too dissimilar to what you guys did with the lunar rover the first time. We looked into that, thought about kind of like almost like an ice stud kind of design where there's like little metal knobs sticking out of the tread. But right now, the one we're most invested in is sort of a paddle. So like almost like a steamboat wheel design, like in the shape, not necessarily the actual design, because the studs would help in a rocky terrain, but they wouldn't do much in sort of a dusty, sandy part of the moon. I think I went over everything. Oh no, I didn't. Sorry. We're doing something I guess is fairly common here on Earth, and that's we're gonna make almost a traditional tire. So one that would be full of air, like you just pump it up. But instead of pumping it with air, we're gonna fill it with that solamide foam. So that way, that's gonna lead to a lot easier transport up, because the tire doesn't have to be, the foam doesn't have to be expanded yet. It doesn't have to take up nearly as much space as it could. We can fold that tire down and make that package much smaller.
Okay, so have you built something?
We have a few prototypes.
Yeah, let's see those.
We
That right there is the.
Yeah. Do you wanna
How about stop sharing and show us what you've got?
Right. Stop share. Jake, come here. This is the one. Here you go.
Okay. So I basically in CAD I made this mold, which kind of in the casting process we kind of broke it. So basically is just this is how we're gonna cast it. And it has like the bottom part of it and then a ring around it, and then we poured silicone into it since that's what our prototypes came out of. And it ended up coming out with this shape, which we chose because like it's squishy and you're able to like grip stuff better with it. Like so if you're climbing a rock, it's able to grip the rock and climb over it. And we also want to do the paddle because then it would be good at like sandy areas.
It'll strike a balance.
Yeah, it's versatile. And then we have just a simple. We don't really know what axle is going to be, so we just made it like a prototype mounting point for the axle. It's just like a hex basically, so like a hexagonal axle would be able to fit in there. And then it's just really squishy and it's able to grip stuff really well.
Okay, so in this case, you're expecting the axle to turn as opposed to turning on the axle. Is that correct?
The axle is yes, it's gonna turn.
It's gonna grip the axle and turn with the axle.
Okay, and that's fine. Now I noticed that it's kind of a flat design. In terms of why did you choose a flat design when you think of like a motorcycle tire is kind of rounded so that it's got kind of curvature?
Right.
Yeah.
So we spent a very long time deciding actually what we were going to use for our idea. We had an idea where we wanted to use cables under tension to provide suspension. We had an idea that was actually nearly identical to the one you guys used on the moon, on the lunar rover. We looked at the Mars rover. We looked at other forms of like traditional tire. We spent a very long time actually deciding what we were going to do. So we haven't had enough time to make this rounded at all.
We didn't really talk about
That's fine.
With the catting process, it was a lot easier to make it flat than it was to like round it.
All of us have kind of just a crash course on CAD. That's what we have right now.
Sure. No. I think it looks really great. I applaud you for the molding process. I think that's a really great idea. The other thought is you've got your spokes so that they go all the way through your wheel. Is that important, or is there value to having them split or anything like that? What are you guys thinking about?
We haven't put. You want to say something?
What do you mean by that? Because the spokes, wouldn't they have to go all the way through the wheel? Or like, how do you touch the outside of the wheel?
Like, you know how bike tires.
Well, like, like on a bicycle, the spokes don't go the full thickness, right?
Yeah.
And so it's not a requirement. It's a question about what kind of rigidity are you looking for.
I think we're looking for a little less rigidity in the actual wheel itself. because like we said, that'll provide the ability for it to kind of mold over rough terrain. Whereas
Okay.
something that would be more rigid might provide a bumpier ride, which just isn't nice.
Sure. Okay. Anybody else comments? Dave?
I think that I'm really intrigued with that type of material. Are you thinking about doing this? You hold that up again so that we can just. So you basically have this whole thing constructed out of this, right?
Right.
As opposed to the spokes being something more rigid, and this is just an outer piece of it. And I'm fascinated by that. I'm curious to see what happens when you do some testing with this. I would be a little concerned that, how quickly is this stuff going to degrade when it's going over a very rough material, right?
So
go ahead.
Good news is this interior part should not be directly exposed to any outside conditions. It shouldn't. I mean, in all possibility, it could. Who knows what's going to happen up there?
Okay, so what's going to go over the top of that then?
We're gonna. Do we have no? Tyga, do you want to come over and show it?
These are from a fire hose that we cut up. This is the outer layer. This is the inner layer, and we're gonna.
What is that material made of, guys?
This is Kevlar.
Kevlar. Okay.
We got it from an.
Wow, you guys have definitely got some innovative things going on here. This is pretty intriguing. Yeah, at this point, I just want to see what kind of testing you get with this, because I haven't seen anything else remotely like that. That's got a lot of potential. I hope it continues to work out favorably. I really do. That's cool stuff.
We actually do have a few tests done.
Uh-huh.
We did.
Have you videotaped any of those tests?
Do we have those?
Did.
Yeah.
I think he added it to
I have the results here, and I have them on the slideshow. I can pull it up. Give me a
Okay.
moment.
Well, and whether we have time to do that or not, I definitely make sure that you're documenting this with video data, right? I think that's really interesting. Whose idea was it to come up with this inner material like this in the first place? What was your inspiration?
Well, for the prototype, like the shape itself, we basically got that because our teacher runs a robotics class as well. And this is like sort of a design they have where it's easier for them to roll over stuff within an arena. And so we just kind of like borrowed ideas from that. And the material itself, we were talking about wanting to start off compact and small and then make it bigger. And we kind of we decided, like truck tires, they have foam with them, like they're filled with foam, which we thought was like a good idea to make it be able to expand more. And then we just had silicone because it was a good prototyping material.
We could get it. It was easy.
Very innovative. Very innovative. I'm impressed.
So what are your thoughts about the material that the silicone it's going to replace silicone?
Silamide.
Okay, that was its Silamide. Okay.
Yeah. We've looked into it quite a bit. There's a bunch of different densities from what we can find, right? Yeah. We obviously don't have a large reservoir of many different kinds of Silamide to play with. So I couldn't tell you right now what kind we're going to use.
Well, we were talking about that particular material because most foams, when they're filled, like air has to go into them and help it like form
That's true,
bubbles.
too.
And so we wanted to have like a more dense foam that doesn't really need that because we don't know what happens if you like put it out in space. Would it depressurize?
Gas.
Yeah, those gases would probably expand. I mean,
Quite a bit.
Very true.
And you also have the temperature problems also.
Yeah, we've actually looked into that, and our outside material is good to go on temperature. Obviously, it's Kevlar based. Here, this is it's kind of covered.
So-
Yeah, I think you are.
So is the Kevlar material what makes contact with the dirt?
Yes. So we've got,
Okay.
as you can see here, we've tested this piece of Kevlar for burning. We put it, did some torch testing on it. We tested how it interacts with a sort of a mock-up of moon dust that we can make here at our workshop.
What did you use for that? Is it just like a fine sand, or what did you do?
Oh, we used to like. It's like kind of toxic.
Mr. Woodbridge did a pretty
We did it with a different group that actually made the sand. It's diatomaceous earth and cement.
Very good. I like that. That's a very good simulant.
Nice comment.
Okay.
Yeah.
And so some of that has gotten buried into the Kevlar a little bit.
So what we did,
and then after some use, it would start cutting it up, presumably, right?
perhaps, yeah.
Yeah.
What we did is we took it and I pressed into it very hard and like rubbed it around for a while to see what would happen just after like initial contact, like what a wheel might be experiencing.
Yeah. And also to prevent like slipping, that's why we wanted the paddle design,
Right.
because it's gonna be able to like grip better if it like becomes packed with whatever the monolith is.
And so how are you going to make those chevrons that you were talking about?
We actually decided against a chevron. We thought about that
Okay.
for a while, but we're gonna do sort of like a almost a dune buggy paddle design.
Yeah.
That's fine.
That if we make them fairly short, not like massive or very small, but kind of a happy medium, they shouldn't be too much of an interference when we're going over rough terrain, which I know is a problem, and they should help in sand where they're obviously best.
Yeah.
Sounds good.
So your design reminded me of what I put in my bike tires. It's some kind of slime that
Right.
if you run over a nail or make a hole in your tire, it fills it. I
Yeah,
haven't had a flat tire forever. Is that what that silicone is?
That was our idea with it, because we thought like truck tires and then also like just like not like healing material that would be able to prevent punctures and stuff like that.
Actually, I had a flat fairly recently. They got saved by that stuff. The
Yeah.
sealant.
Yeah, it's real. Is that what you were? Is that similar to your material? I like it because it seals my holes. And I don't get stuck anywhere, which would be real important for the astronauts on the moon not to get stuck.
It would not. Yeah, our design will be. It'll be like it'll be a wheel made of foam.
Yeah.
So it
that
doesn't,
wouldn't be that big of a deal because it's not pressurized and you don't have to worry about air leaking.
Exactly. A hole in the tire might cause structural damage. Like it actually might damage the tire.
But it wouldn't.
It wouldn't deflate. No.
Yeah, that's good.
Yeah.
That's an important aspect of designing. I love what you're doing. That's awesome.
Yeah, we also considered like bringing the mold itself with the astronauts. That way, if a tire does get damaged beyond repair, they could just make another one. But we don't know because
the foam can pack down.
Yeah,
it's expanding. So,
but we don't know how well that would like what you guys would want to do with that, because maybe you don't want to bring the extra weight. But I'm not sure.
Right.
No, very nicely done. Good work. Yeah, and make sure you do take videos of all your testing.
We do have some videos, but I think we're getting. Are we out of time?
No, we have 10 minutes.
We have 10 minutes. Oh,
I think we have 30.
No.
Now there's another wheel team that has the next 10 minutes. Sorry, guys. You have 2 wheel teams, is that right?
Yeah.
We do.
Yep.
Okay.
So there's another wheel team that's up now.
Yep.
All right.
Thank you.
For your time, guys.
Thank you.
Good job, team.
Thank you.
Keep it up.
And this is your last team, right?
Yep, this is the last group.
Awesome.
They're not.
All right, Mr. Woodbridge.
They're meeting as a club. So.
Mr. Woodbridge, I am loving the shirts that you've got there. Those are awesome.
We made patches this year because we wanted to be fancy.
Yeah,
You guys are awesome. I'm jealous. I like that you guys have a different patch than I have. So
Well, when we see you, if we get a chance to get to Johnston, we'll bring you one.
I would love one. That would be great. I wear lots of patches. So
So while we're waiting, I just pulled up this polyamide foam. This was developed by NASA.
oh, was it?
Yeah.
And so what's the low temperature range on it?
Let me, well, I'll have to. Hang on.
That would be my biggest concern with it, but I have
Well,
no
there
idea.
seems I've got a lot of options here. There's a YouTube titled "Solomide Foam in Extreme Temperatures."
Oh, really? Okay.
Yeah, looks
Send me
like-
a link to that. That sounds awesome.
Looks like they're. Hang on.
You
can go to any of them.
Yeah, they're all same. All right.
I just sent it to you, Glenn.
Okay, thank you.
Hello?
Cool stuff.
Yeah. So we don't actually have anything out yet because our main principle is blue sky development, where what we do is we just throw a bunch of stuff at the wall and see what even remotely sticks. Whatever does, we will put it through the testing phase, which we've really yet to. On the left, you can see basically the key stuff that we've thought of. Chainmail tires, replaceable parts, spokeless wheels, Kevlar material, which was recommended to us by bike shops. A 6-inch diameter and 3-inch width wheel. Suspension shocks, maybe we can make it wider, taller, we don't know. Tomato filling, like push pins. When you have a sewing kit, you have a tomato that you push in, push out, it heals itself back up without leaking. So we thought that could possibly be used for a tire. Bike spokes or just regular car wheels we use, and walking tank treads. So it'd be like metal plating for a tire.
Yeah. We've mostly been doing research this entire time, whether that means like looking up certain materials or looking at the requirements and finding maybe what meets or what could work. And we've gone to actual like tire shops and we've asked them questions and whatnot. And they're actually the people that recommended Kevlar and some other things. And we've been doing research onto like different types of tires that have been used in space by NASA already. So, yeah.
That's wonderful.
Yeah.
And then once we actually have some designs that we like and we're willing to stick with, we're thinking that we're going to put them through the testing phase, put them through a series of tests, mainly seeing how much they weigh, how much they cost, how good they grip stuff. We're using the same sand mixture as the last group. So we're going to be able to see how dust particles are able to get into the wheels and ideally stop that. We're thinking of doing temperature testing so it doesn't explode or crack. Pressure testing of both, if it's higher, seeing what happens when you change the air inside of it and what happens if you decrease the pressure outside of it. Punctures and slashing, those are two types of damages that will be seen, so finding ways to reduce that through testing can also be done. And then we're going to take all the plus and minuses of each design and come up with final results. And whatever comes out well, comes out well.
Yeah, right now we have a couple like very extremely preliminary design ideas that we want to start testing like really soon, like probably the next time we meet, or create it and then test it. And then we want to see what happens like when we try out these certain things, like what elements maybe don't work and what elements do work, and then culminating all these different tests of different types of wheels to making like a better wheel or more ones that we can then test again and on and on the process, so that we eventually can have just like one really good wheel that works really well and doesn't like have all of these problems.
And it's important to keep your results from the failures as well as the successes, because the failures tell us something also.
Yeah.
So keep that in mind.
Yeah. Thanks.
That's what we have to present here.
Well, we could also tell them about what our designs are.
Oh yeah. Currently there are two ideas that are really sticking with us, and that being a chainmail tire
So, or maybe twin something similar to it. Something that's slash resistant tire on the
Like-
outside,
Like
steel wool, with a tomato, like the sewing tomato.
like if you
Sewing.
sew and you have that thing that you've got to put all your pins into
Yeah.
and your needles, right? That's got like metal on the inside of it, and you puncture it with sharp items, but it maintains its like stability or structure. And so that could work really well for a wheel if it's got to sustain sharp stuff being poked into it, like rocks.
It also wouldn't be leaking pressure.
Yeah.
So should it be stabbed, it won't leak because it's just material in there.
Yeah.
And then the other design is more just spokeless. So instead of having spokes that are easy to get dirty, it'd be spokeless. It would be through the wheel rather than being exposed to the outside.
Okay. So choose one of those. Do you have an idea of how you want to assemble one for your first prototype?
Yeah, kind of. So for like the steel wool one, when we went to like a bike shop and he went to a bike shop and was like given some information, asked some questions, or got some information about like Kevlar was one of the things they actually really recommended. That and spokeless wheels. But so if we had like steel wool, we could maybe wrap it up in Kevlar, and Kevlar isn't stab proof. And so that's like fixes. Maybe we'd have to test it, like a puncture thing. And so it would be like we would have like steel wool or chain mail, and we would like wrap it to make sure it all stays in one piece. We would wrap it in like a layer of like Kevlar fabric, and then that would go onto a rim or the actual like a tire part. And then that would have, you know, a spot for one axle, we decided, and that would be like your wheel.
Okay. And so, and I'm a little bit confused what you mean by spokeless. Does that mean you have like a big disc that keeps the shape, or what are you thinking?
So spokeless wheels are currently being tested because they're much easier to keep clean than wheels with spokes. If you look at a bike wheel, you can get rid of the hub of it, and you can basically be a rim that's held in place by the main body it's moving. The chain would then move from the body through the wheel, like basically between the rim and the tire. It would move through there and then connect back up to the body. So instead of having the bike chain go to a hub and then back to the pedal, it would go from the pedal or motor to the wheel. And then that's how I'd gain momentum.
I'm having trouble picturing that personally.
Yeah, it's strange.
I need to see some diagrams to get what you're saying.
Yeah.
If you Google it, and it's kind of hard to Google because it's being tested right now, but if you Google it, there are some images, but a lot of them are like fake and whatnot, but you'd have to do some good research to find like the actual ones, but there are some examples because it is being tested right now.
Okay. Well, but okay. So the whole point that we're trying to get to is, what are you going to make?
We're still getting there. We still
Okay.
Right now, we're figuring out what ideas we want to actually use. We barely have much time to wait, so it's hard to get the ideas, but that's no excuse.
Okay.
We just
And
we're going ideas, seeing what sticks, and now we're going into testing.
Yeah, like
sure. And so what I'm trying to get to is that, you know, you're kind of far into the year where you should be having, you need to choose something and start working it so that you can see how it works. Because our whole point is to try to get the ideas from your head into your hands.
Yeah.
And so I think these are all great ideas. I think you just need to choose one and decide how you can assemble something.
And I really appreciate your research on that. And there's one other thing that not very many people are looking into, and maybe you have because you've taken the time to do all this research, and that is how to eliminate some of the dust from flying up and, you know, getting on the astronaut suit or even in his space. And maybe there's a design that would eliminate some of that. I guess you'd have to test different designs out for it, but that's an aspect that is not talked about very much, but I think with all your research, you might have found something. And take videos if you do any testing on that. So thank you so much for that. I appreciate it.
Yeah.
Do you have any questions for us?
Yes, we do have a couple. One of them being is, so one of our ideas incorporates like steel bore chainmail, like we explained. And while we were doing research on that, we actually got the idea of that from, apparently NASA is developing like rover wheels for Mars, and they are like chainmail wheels, and that is to prevent like, you know, puncturing it being punctured and like, you know, the tire being ruined. So we were kind of wondering like, what like,
we're kind of wondering what exactly is the difference between NASA developing wheels and Hunch designing them? Because there's already so many models out there created by NASA, and how many
Sure.
are like effectively either taken from them, used by them, or even
So most of the wheels that are being designed for a lot of these other projects are specifically wheels that only have to go centimeters per hour, or I mean centimeters per second, as opposed to miles per hour. And so you guys are developing something that's a little bit different. As far as I know, the only wheels that have been developed for going on the order of 10 miles an hour were the original Apollo lunar rover wheels. But that was one set. I think that there are a lot of new options that are available today that we can do, especially with new materials and new capabilities, with whether it's 3D printing or whether it's, you know, nitinol, which is one of the materials you're referring to. So I think we've got a lot of good options that students can come up with. And the other thing is that these wheels are for a two-wheeled vehicle as opposed to a four-wheeled vehicle. And as you can imagine, there's a little bit of difference in terms of how you lean and turn with a four-wheel vehicle as opposed to a two-wheel vehicle. So that I think we've got some very new requirements for this particular wheel design.
Yeah, and an
There's
astronaut's
also
going to
another
be on it.
consideration.
Go.
So when on a project like this, NASA will put out what's called an RFP, a request for proposal, and you know they'll put that out to every company that wants to submit something, because they're looking for as many different ideas and innovations as they can. And if I may say so, sometimes our high school students do a better job of designing than NASA engineers do. So that's why you're working on it.
Figure we've been making wheels for other places like the moon and Mars for about 50 years, and we haven't solved the problem yet.
That's right.
Yeah, that just gives us more of like what like problems we're trying to solve. Like you were saying, like it's mostly like the wheels that have been used are for centimeters in an hour and not miles. So that gives us like a really good, like that's a requirement we definitely have to meet, is that it can go fast and not like mess up or screw up.
Right.
Martian soil is a lot different than lunar soil as well. We haven't really built a lot of rovers to drive around on the surface of the moon.
Right.
So that's part of your challenge. Lunar regolith is very abrasive, you know, stuff.
Yep.
And what Dave said earlier to you, like you really need to just build something and test it out and see what and see if your ideas are interesting. Now let's see whether or not they survive testing.
Yeah.
Yep. Okay. Well, thank you so much. We really appreciate all the work that you're doing, and everyone in Olympia High School and Mr. Woodbridge. We really want to thank you for all your participation there this year. You have some awesome teams and students.
Thanks. Yeah. And this last group has been meeting as a club because they liked it so much last year. During class, they actually have been meeting once a week during our enrichment bear time. So
wow.
Excellent.
They're
Excellent.
A little bit behind. That's why. So
yeah, that's
Understand.
Okay. We can certainly use their work. Thank you for meeting. They don't get credit. We appreciate that. All right. we have one more team for today who also meets as a club, not as a class. And this is the first year that California in Pacific Ridge High School has one team, and here they are. And they are doing the dice project. Hi, everyone. Good afternoon. So, and thank you, Mr. Woodbridge. That was awesome.
Okay, so
you can share your screen, introduce yourselves. Their teacher, Mr. Burrows, is like an activity teacher. He's not a science teacher. They're just doing this on their own.
Very cool.
Yeah.
Excellent.
Okay.
Yep, and we are getting our screen share set up right now.
Yeah, we saw something.
So we have 4 people on our team, and I'll start talking while they're getting the slide up. So this is David, this is Jaden, I'm
Hi.
Chloe, and this is Selena. And we're not actually a club that our school just offered. We just, David found out about this, that's a hunch. And then he decided, oh, this is cool, we should do it on our own spare time. So we gathered every Monday after school and just talked about the ideas. And it's really cool that it's actually happening in your life. So
we really are glad that it is happening. That's cool.
Yeah.
And you really have to thank David. He didn't give up on emails. I said,
oh. So yes, good job, David.
Are you guys able to see this?
Yes.
Yes.
Okay, cool.
Okay, great. Yeah. All right.
Black screen.
All right.
All right.
So yeah, like we said, we're Pacific Ridge School, and this is our first year, and we're doing the dice roller. And just a little bit about us and why we did it. So Chloe.
So I'm Chloe, and my favorite game is Clue, including dice, because I like just guessing. Yeah, David.
And yeah, hi, I'm David, and I really did this because I really like dice games, and my favorite dice game is Yahtzee. I really like using the dice kind.
Hi, I'm Jaden, and I'm a big fan of Monopoly.
Hi, I'm Selena, and my favorite dice game is Quicks.
And none of you guys are role-playing game people, or?
Okay, I play some D&D.
Okay.
So
Now what was quick? Is that what I heard you say?
Quicks is just a dice game that you can play with a big group of people.
Okay. I don't know that one. It just sounds cool. Okay.
So we chose this project because we're aware that going to space is a daunting task. You know, you're just floating in the void of space, completely disconnected from everything you've ever known. And that can be a big issue for some people, leading to mental health issues and even depression in extreme cases. But dice games represent an excellent and fun way of lowering this risk and improving mental health and teamwork. So it has some immense benefits towards teamwork and team bonding, allowing astronauts to not only entertain themselves, but to also build better teamwork with their partners. And it also provides an excellent mental exercise and reduces anxiety through the simple act of having fun and playing a game. So in the process of doing this project, we actually ran a poll. We made a Google Slides form and sent it out to our school. The main gist of the questions we asked were, do you prefer physical dice or online dice? And we have seen the resounding majority likes physical dice more. And we also asked another question about what is the favorite part of rolling a dice for most people. And we got answers ranging from the feel of the dice in their hand to the sound of the dice when it hits a table, which really shows how much having physical dice really adds to the experience of playing a dice game.
Yeah, and we got around 117 responses, so we were really happy. We got some voices from our upper school. Okay, and then
as for our prototype requirements, instead of using gravity like we would on Earth in space, we have to have a substitution force, such as centrifugal, electromagnetic, applied, etc. And then we want the users to have the most interaction with the dice while playing. So you do get to like roll it into the product and then shake it up and so you can get that randomness. And then the size must accommodate a high quantity of dice and it has to fit in a hand. So it is like kind of small, but still enough to hold multiple dice. And it should be lightweight for space. And then so for our materials, we would mainly be using Lexan, which has a high level of impact resistance. It's low rigidity and can handle high temperatures. It's highly resistant to acids and other chemicals that may be coming in contact in space. And then it can be drilled without worrying of cracking. It can be cold formed or bent without heating and low level of flammability.
And adding on to that, while this is going to be our final prototype, it's going to be made out of Lexan. For the time being, we're going to be making it out of acrylic just for ease of use and because of the materials we have on campus.
Okay, so this was our first drafting stage. It was very different from what we actually ended up bringing today with us today. We first began by brainstorming and we thought of lots of different things like Velcro, magnets, electromagnet. We even thought about spray painting with a magnetic spray. I don't know how we came up with that, but we were thinking of many different things of how we can still get that randomness. Oh.
And then one second, sorry.
Sorry, we accidentally skipped ahead a bit.
And then just making sure you guys can all see the presentation still, right?
Yes, it's only half the screen, however. I don't know if you can make it. Yeah, now.
Yeah, all right, there you guys go.
There we
Yeah,
go.
that's better. Thank you.
Yeah.
So this was our second drafting stage, a little more similar to what we have now. And we thought of the game Yahtzee, and you have a cup and you put your dice in it. And then we thought in space, since we don't have gravity, you're gonna need something to push against and hold the dice in place to be able to see your random number. So we came up with a slider where you could push down with 2 finger grips on the side outside of the cup. And you would press down on it and it would hold the dice in place and you would be able to read the number from the bottom of the cup. So yeah, we came up with a plastic cup and we soldered the sides so that we would have 2 slits for the finger grips to stick out at. And then we made that come true. Do you want to show them the actual model?
Actually, so although our very first draft was indeed basically soldering plastic jars to create our rough design, we eventually decided that was a really rough way of doing things and that we could do better. So we made this CAD design in Onshape and we laser cut it in acrylic to produce our prototype, which we have right here. So the gist of it is this goes up, you put the dice in here, you can shake it around to get that randomness, and then you slam this down, trapping the dice against the bottom. And as you can see, the entire thing is clear, so you can see through it and see what your roll is. But this solution does have some minor issues we're looking to resolve.
But before we get to that, do you guys have any questions about how we're using applied force in this thing or just about our design in general so far?
So Jaden or David, I don't know who's talking, but were you showing us something? Because you froze. We see the video, but we didn't see you.
Yeah, we'll show like an actual, we'll just show like a physical like showcase of it after we finish the slides.
Yeah,
so then,
that'd be good.
So yeah, the pros and cons of this design was the pros were like using a polycarbonate or an acrylic for this. It makes the material still very clear, which helps out a lot. And then while you're shaking it, we'll show this later, but you still have that dice-like motion and feel in there. And then one of the main things is that we checked and it keeps it still very random. It doesn't affect the randomness at all. And then it also allows it to be easy to use and change out the die because like if you're playing a game like D&D, you don't want to spend like 10 minutes swapping out your D20 to a D6 or a D4. So you're gonna that's a great benefit of it. And then some of the cons, Sally, is that it's large and hard to hold if you have small hands like mine. And it's also annoying because while it's easy to swap out the die, pushing the plate back up and down is quite time consuming. And so to remedy that, we made a third draft prototype where we made the top spring loaded. So it's now a lot easier. This will come into play later. And we also added hinges to it to make it even easier to open and close. So then we also have this video of it working. And then in it, you can see like how the spring is keeping, we can compress it. We put the die in later.
And I'd like to add that this would not be the final draft of this specific idea. This is just a rough draft it came up with. For the final, we would laser cut it again to make it more neat, and we'd probably use a more springy spring.
Yeah, but in this you can generally see how it would be floating around in there as you shake it up in the way you shake up the die. And then you could then like push down on it and then look at the bottom like we showed there to see the number of the die.
Nice.
And then yeah, let's do a physical showcase now of both of them.
So stop sharing.
Stop sharing, yeah. Okay,
Yep.
So we have, this is the laser cut design. Oh.
Yep. We see you now.
See it fine.
All right.
This is the laser cut design. So as you can see, we have
2 slits on the
this
sides.
plane in the center that you slide up and down. So you'd put dice in here, not here. So we'd put dice in here. Then you'd put the plane on top. And again, this is just a rough draft. So then you'd shake the dice around, and then you'd put it down and trap it. And your result for this example is a 2.
And then,
I like your design. I think you guys have a good simple design there.
Yeah.
So the number one thing is randomness, and it looks to me like you've got plenty of randomness. The next thing is fun. Do you guys feel like you're preserving the fun?
You love this.
And then in the second one, yeah, there's 2 benefits to the second one. Like one, the spring alone, that's almost as much fun as playing the game.
It's like a physics.
Yeah. You still have that motion like shaking a die, and then you can push it down, and then you can like look at the bottom, and then oops.
It's here.
Oh, yeah. And then you like you got a 2 and a 3 there. So yeah, I really think that the randomness and the fun, we prioritize both of them, and I really feel like we pulled through on that.
I personally think the spring plays a really big role. It's really fun. It just comes back out.
I love your idea. As I'm watching you do it, I didn't realize at first that you had the default condition, the spring up in the top. What if you had your dice on the top so that when you weren't holding it, it was pinning the dice in the top? So when you go to shake it, you open it up, shake it, and then let it. And then
yeah,
that's actually a really good idea.
Yeah,
We
like
didn't
put the
think of
spring on
that.
the inside instead of the outside. Not right.
Good suggestion.
I love it's it's simple. It captures the rules that we wanted you to follow, and it's interesting. Now, have you tried other dice other than the D6s?
Yeah, we have.
Yeah, we worked with everything like D20s, everything. Yeah, we
Even
tried it out.
D4s. I'm wondering about the D4 shape.
D4s are an interesting case because it works almost every time with D4s.
Yeah.
But if you catch it at the exact wrong angle, you might end up pinning it upside down. But that's pretty rare. So you can just shake again and it should go right side up that time.
Yep.
And
it's just
also,
like a dice rolling on it, hitting on its side and angle on it against. So no, that's
and
fine.
Also, an add-on we had to that to help improve it and counteract this is we were thinking of, instead of like we were using a normal plate, we were thinking of making it like a more like flexible, kind of like a saran wrap as well, just because if we had that, then it would be able to conform to the die, making it so that it would be impossible for it to balance on like one corner because it would just push it down and then you get an answer. So that's one of the
It would also make it more flexible for different dice sizes, which is something we're also looking at.
Now, a D4 is interesting because it can come down where it's the flat side down, or it can come down and it's the pointy side down.
But they said it's rare. They said so.
Oh,
it's pretty rare, and you can just re-roll.
Do it again. Yeah.
Well, yeah. See, in space, though, it's probably going to be a 50-50, isn't it?
I don't think so. I think it hitting it will twist it enough that give it a side torque.
Yeah.
Well, what I mean is, so you've got a 50% chance of it being on the flat side or it being on a pointy side. When you don't have gravity, to help twist it around.
Yeah, it's
Now,
definitely
I don't know about that, but it's just an interesting conundrum there. And I think you're saying it right. If you can't read it, you just flip it. You just do it again.
I think it's a good idea to test it. So we tried testing it in a pool where you'd have less gravity. I think it's a good idea to see what a D4 dice would actually do in the pool.
that is something we'll definitely look into going forward.
And plus, adding on to that, even with the idea of, even with a material like this, it does conform, it's still bendy, it conforms to the die. So like, even in space, you're still putting that applied force onto a die. Actually, I'm just gonna use an example with one of these dies. You're still putting that, let's say it's bouncing on its corner like this. You're still putting that applied force on it to push it
twist it,
one side, and then you can then get your result. So even though it's still an issue right now, we do have result answers and like ways to fix it and remedy it.
Awesome.
Okay. Now I'm going to give you another thought. So we talked about randomness. We talked about fun. What about style? What kind of style, if you are the astronaut going to Mars and you are looking at playing these games, what's going to make this thing so that everybody says that is the coolest dice shaker, I want it?
So I think two things come to mind when you say that. First of all, I think we were talking about earlier, the spring is really fun to use because springs are awesome. And also another interesting thing is this is like, in a way, a maraca, you know? Like it's multi-purpose, doesn't only have to be a dice roller. You can do music with it. You can got a little fidget toy with the springs, 1,000 different things you can do with it.
And plus, due to the design, it allows us to make it in a bunch of different shapes. This is just like a basic one with like a box we got at a store, but there's nothing stopping us from like 3D printing a rocket ship or like a design the astronaut specifically wants. So like we can really, the designs are limitless for this. We can really make it like any design, any color, any type we want, and it still have this functionality and purpose.
I think we
You know, the future in marketing.
And that's part of what I was thinking about is, you know, if you make it the shape of the Millennium Falcon, what does that do, right?
Yeah.
Or should it be the shape of, you know, the Enterprise, or is it the? So what I'm thinking is make it so that it fits what you guys are interested in, because potentially you are the astronauts going, and then if you make it match for what you're interested in, we may find that there's other astronauts with that same kind of idea.
Cool.
And don't forget, if you come up with something really cool and this goes far enough, you can always patent this. There could be a market out there someday.
No, wouldn't it be cool if the astronaut had it up on the space station or wherever, and his children back on Earth could play with him, and they could tell each other, they could play against each other, because they would have one to do, because that will work on gravity just as well and be fun. So maybe we can make it a family affair, not just a astronaut affair.
Yeah.
We just play it in a museum if it's historic.
Yeah. No, I really think that is so simple. It's beautiful, needless to say. And you did a great job. I know you meet after school, and that you just came up with some great ideas that you kept in your mind what we were looking for, and made it work, which is awesome.
I'm really impressed. Are you guys all seniors, juniors?
We are sophomores.
You're
Sophomores.
sophomores.
And you just decided to do this on your own?
Yeah, I heard about it somewhere, and I came back, and we got some friends together, and we all were really passionate about it, so we decided to do it. Yeah,
we had fun with it too.
Very cool. I'm really impressed by your initiative.
No, we appreciate your work on that. So also make a neat name for it. Come be creative. You could make a name, make a patch, make something to add to the coolness of it.
Oh yeah, we totally
We don't
could.
need to work on the market.
Yeah, market it.
Oh, you don't know the extent of what this could be marketed as.
Yeah.
Okay.
Did you have any questions for us?
not really, no. Yeah.
Okay. Good job,
Okay.
team.
Well,
Thank you.
Thank you.
thank you so much, and thank
And-
Mr. Burrows. What was
so
that, David?
We had one small question. So we noticed that since it's going to space, one of the main factors is weight, because when you're going to space, every ounce, every gram, it really counts because you just cost so much money. So we're wondering about like, is there like a general like weight range that we should be aiming to get? Because we know, like, for instance, the acrylic can be a little bit heavy. So we're looking to like, should we be looking into lighter options? Like should we be having to stay like about like, yeah, like about 8 ounces? Like what's the like weight range for this?
No, I think the right now worry about getting it so that it's operational, so that it's cool, and then we'll worry about weight later. Okay.
All right.
Yeah,
Okay.
and you said you were going to use Lexon. Was that your team?
Yes.
Yeah, that's perfect. That's what we send to space. So that's good research on that one.
Thank you.
Thank you.
All right. Well, thank you so much. Enjoy your afternoon there. I bet you had nice weather.
Yeah. Thank you.
We had our first snow here.
Yeah.
Hey, I've got almost 3 feet.
They meet.
Holy cow.
Come on, guys.
Actually, when I meet with them, they're outside usually. So I said, oh my goodness, it looks so beautiful there. But that was good. No, David was the instigator of that. And he got a teacher and then he got a team. Couldn't complain.
Excellent.
That's awesome.
Yeah.
Okay. All right. So we got more tomorrow. Is that right?
Thank you. Yeah. So we're supposed to come at 7 tomorrow to talk to the
Yeah.
team that had the fire
Fred's team.
alarm. Fred's team.
Yeah.
And
Wait.
actually the team sent me a PowerPoint, which I will send to you. 7 my time, 8 your 8
9.
Dave's time, 9 your time. Sorry.
Okay.
I'll
All
send
right.
you the
See you
I'll send
guys
you their
tomorrow.
PowerPoint. Yep. Thank
Okay.
you so much for joining me. I really appreciate it. Did a great
Okay.
job. Thank you.
I'll see you guys
Bye-bye.
later. Thanks a lot.
Yeah.
Bye-bye.